Algebra 1, Lesson 59, Solving Systems of Linear Equations by Substitution. We have two equations here. They're linear equations, meaning if you were to graph them, then they would make a line. We need to solve them. When they ask us to do that, they're asking us to find out where these two lines would cross, the point at which they would cross if they were graphed. So we're looking for an ordered pair, x comma y. The easiest way we can do this is by using substitution. You want to make sure your equations are solved for either y or for x. In this case, they are solved for y. Y equals mx plus b is the form. So what you need to do is take either your first equation, I'm going to label it like this, or second equation, and replace y. I'm going to replace y in my second equation with 2x minus 5. So if I do that, I'm going to rewrite this second equation, y equals 5x plus 7, but instead of writing y, I'm going to write 2x minus 5. I'm substituting 2x minus 5 for y. Now I'm going to write the rest of the equation. It equals 5x plus 7. Now there's only one variable. We can easily solve for x. To solve for x, we'll add 5 to both sides. Over here we have 2x. Those add up to 0. On the right side, we have 5x plus 12. To solve for x, we combine our like terms. So we subtract 5x from both sides. 2 minus 5 is negative 3. These add up to 0, and we're left with 12 over here. To solve for x, divide both sides by negative 3. They cancel. So x equals 12 divided by negative 3. It equals negative 4. We found the x for our ordered pair. To solve for y, we're going to take negative 4, and we're going to replace x in either our first equation or second equation with negative 4. It doesn't matter. You'll get the same answer. I'm going to use the first equation, y equals 2x minus 5. I'm going to replace x with negative 4 and solve. Negative 8 minus 5, because 2 times negative 4 is negative 8. Add those together, you get negative 13. Our ordered pair is x comma y, so it's negative 4, negative 13. That's where, this is the point, if you were to graph these two lines, one would be going down and one would be going up. This is the point where they would cross at negative 4, negative 13 on the graph. Now, what if your equations are given to you and they're not in the form y equals mx plus b? That's okay. If they're here, if they've solved for x, then that's also another easy way to substitute. Here, this equation is not in the form y equals mx plus b. It's called a slope-intercept form. But down here, they solved for x, so what we can do is our first equation and our second equation. We can take whatever x equals, negative 2y plus 11, and replace the x here for this, negative 2y plus 11. I'm going to rewrite my first equation. Instead of writing x, I'm going to write negative 2y plus 11, and then write the rest of the equation. Okay, now to solve, I'm going to use distributive property here, on this right here, not the rest of the equation, just this first part. 12 times negative 2y is negative 24y. 12 times 11 is 132. And then now write the rest of the equation. I can solve for y. Add 6y to both sides. We have negative 24 plus 6, and I'm sorry. These are on the same side of the equation. Add your like terms together since they're on the same side of the equation. Negative 24y and negative 6y is negative 30. We have 132 as our constant on the left and 12 as our constant on the right. Now we want to get our y by itself, so we're going to subtract 132 from both sides. Negative 30y is what's left on the left. This adds up to 0. 12 minus 132 is negative 120. To solve for y, you divide both sides by negative 30. Those cancel. You can cancel the zeros, so now you're just left with negative 12 divided by negative 3, which is positive 4. Y equals positive 4. To solve for x, you replace y in either your first equation or your second equation. Looks like our second equation would be easiest to solve for. So we have x equals negative 2y. I'm going to replace y with positive 4 plus 11. So solve. Negative 2 times 4 is negative 8 plus 11. X equals 3. We can write our ordered pair as 3, 4. Now, this equation right here, example 3, we have two systems of equations, but it's not solved in this, it's not in the slope-intercept form, y equals mx plus b. So we can take either our first equation or our second equation and solve for whichever variable we think is the simplest one to solve for. I think y is going to be the simplest one to solve for, so I'm going to use equation 1. I'm going to solve for y. To solve for y, I'm going to subtract 2x from both sides. Adds up to 0 here. We have y on the left. Negative 4 and negative 2x are not like terms because there's an x here and not here. So it's just going to stay the same, negative 4 minus 2x. Now we have our first equation rewritten in slope-intercept form, y equals mx plus b. Now it's going to be a lot simpler to substitute. In my second equation, I'm going to replace y with negative 4 minus 2x. 5x minus 2 times y, which I'm going to replace with negative 4 minus 2x, equals negative 1, and solve. I'm going to use distributive property here. So 5x stays the same, and then negative 2 times negative 4 is positive 8. Negative 2 times negative 2x is positive 4x. Add or combine your like terms, 5x and 4x, you get 9x. To solve for x, subtract 8 from both sides. And then divide both sides by positive 9. Those cancel. This cancels 2. You're just left with negative 1 for x. To solve for y, you can take this negative 1 and replace x with it in either your first or second equation, or you can go down here because remember, the first equation, we rewrote it this way. You can do any of these equations and you'll get the correct answer for y. I'm going to use this one that I rewrote. Y equals negative 4 minus 2x. Just a few less steps. We're solving for y and we're going to replace x with negative 1. If we solve, we have y equals negative 4 plus 2. Y equals negative 2. Now, write as an ordered pair negative 1, negative 2. If you were to graph these two lines, they would cross at the point negative 1, negative 2. Make sure you're writing your answers as ordered pairs. Now, the last question is example 4. It's a word problem. It says a school play charged adults $8 and students $5 for tickets. There were 75 people who attended the play. The box office collected $444. How many adults and how many students attended the play? And we're going to use substitution to solve this. First thing you have to do is figure out or define your variables. So in our last equations, we had x and y as our variables, and that's the one you're probably going to be most comfortable with. So let's say that x is the number of adults, or the adult tickets that were sold. Y is going to be the students. This is x, this is y. Now, let's write an equation. We need to write two equations because that's how we're going to solve for how many adults and how many students attended the play. If we add our x and y together, or if we add the adults and students together, the total number of people is what we'll get. Well, they told us that 75 people total attended. So we can say x plus y, or adults plus students, equals 75. That's our first equation. To find the second equation, we're going to use the other thing that they gave us. They gave us money. They said the box office collected $444. That's the total that the box office collected. It was $8 for an adult ticket and $5 for a student ticket. So you're going to use 8 and 5 as your coefficients. In front of x, because that's adults, we're going to put 8 because that's the cost of an adult ticket. In front of y, we're going to put 5 because that's the cost of a student ticket. and the total amount of money they collected was $444. So we have an equation with the number of people and we have an equation with the cost. So now to solve, we have our first equation and our second equation. What we need to do is solve for either x or y. I'm going to take the first equation and solve for x. X plus y equals 75. I'm going to subtract y from both sides. On the right, or on the left, we have x, and on the right, we have 75 minus y. They are not like terms, so it's just going to stay as 75 minus y. I rewrote my first equation, so now I can substitute 75 minus y into my second equation for x. So I'm going to rewrite the second equation and replace x with 75 minus y plus 5y equals 444. Now we've got some big numbers. You can use your calculator or you can do 75 times 8. Okay? We're using distributive property. So 8 times 75. 8 times 5 is 40. 8 times 7 is 56. Plus the 4 is 60. So we have 600. And then 8 times negative y. So minus 8y plus 5y equals 444. Add your like terms, your y's. We have 600 minus 3y equals 444. To solve for y, we're going to subtract 600 from both sides. Again, you can do some work over here or use your calculator. On the left, we're left with negative 3y, and on the right, we have 444 minus 600. It's the same thing as 600 minus 444, except it's going to be negative since 600 is the larger number. So negative 156 is what we get. We want to solve for y, so we divide both sides by negative 3. The 3's cancel on the left. Y equals negative 156 divided by 3, negative 3, which is going to be a positive because two negatives make a positive. If you want to do 156 divided by 3, you can do long division. That'd be 52. So we have y. We've solved for y. This is the amount of student tickets because y is students. They sold 52 student tickets. Another way that you can solve for the adults is you can just do 75 minus 52 because there's only adults and students. So to find the adults, you do 75 minus 52. And you're going to get 23. Or if you still want to keep using your equations, this equation right here is the first equation that we rewrote. So we can use this, and it's going to be x, or the number of adult tickets that were sold, equals 75 minus y, and y we know is 52. Look, it's the same, 75 minus 52. So x equals 23. So if we write it as an ordered pair, 23 is the adult tickets and 52 is the student tickets. And that's your answer. So your homework is lesson 59, practice questions A through E.